How to build the sensor box. Here we are looking at the hardware assembly. The video is intended to be used with our documentation that provides detailed step-by-step instructions with tricks and tips on how to build the sensor box. Let's first work on the sensors and processing board, starting with the preparation of the components. Add an SSD drive to the NVIDIA Jetson Xavier NX development board. Change the ribbon cables from the two Arducam Sony IMX219 camera modules against two 30 cm long ribbon cables. Solder breakaway headers to the components to expose pins for easy wiring with jumper cables, like here for the ultrasonic rangefinder to provide a serial interface to the UART of the microcontroller. Solder jumpers to set up the desired configurations, like here to enable TTL signals. Use a carving knife to cut the traces between jumpers. And solder jumpers to set up the desired configurations, like here changing the I2C addresses of the IMU. Let's take a look at all electronic components of the sensor box with the modification we made. Two Arducam Sony IMX219 rolling shutter RGB cameras. With two SparkFun LSM9 DS1 IMUs and SparkFun quick adapters. An Intel RealSense D435i RGB-Depth camera. A FLIR Lepton 3.5 thermal camera on a Group GATS Pure Thermal 2 module. A MaxBotix HRLV.MaxSonar EZ4 Ultrasonic rangefinder. A SparkFun Redboard Turbo development board, at the heart an Arduino Zero. A SparkFun Neo M9N GPS. A SparkFun IMC20948 IMU. A SparkFun LPS25HB pressure sensor. A SparkFun TMP102 temperature sensor. An NVIDIA Jetson Xavier NX development board with a Wi-Fi and Bluetooth module and SSD drive. An UC-Tronics 5-inch HDMI touchscreen display. A SparkFun USB-C power delivery board. A ZIO INA219 current and voltage sensor. A power push button. A power add USB-C power bank. We use matrix screws and threaded heat inserts. Insert the threaded heat inserts with a soldering iron into the 3D prints. Stick pads to the underside of the bottom plate. Let's take a quick look at all 3D prints with the threaded heat inserts. The bottom plate, the power board, the vision board, the battery stands, the sensor board, the processing board. Now we move on to the assembly of the sensors and processing board and attaching the components. The assembly is based on screws to make it easy to replace components. Slide the vision board onto the bottom plate. Use screws to attach it firmly. It is easy to design a new vision board with a different camera or sensor suite to replace this one. Attach the cameras and sensors to the vision board, the thermal camera, the ultrasonic rangefinder, the RGB-Depth camera, the two RGB cameras, with the two IMUs next to them. Here's the vision board with all its cameras and sensors. Attach the battery stands onto the button plate. Use two zip ties to attach the USB-C power bank to the battery stands. We use the Arduino IDE on the host computer to configure the SparkFun USB-C power delivery board. The Arduino IDE can be downloaded for free from its website. We already downloaded a copy. Install the Arduino IDE. Install Arduino's SAMD board add-ons for the 32-bit ARM Cortex-M0 Plus. Install SparkFun's SAMD board add-ons for the SparkFun Redboard Turbo. Install SparkFun's STUSB4500 library for the SparkFun USB-C power delivery board. Connect the SparkFun USB-C power delivery board with the SparkFun quick cable to the SparkFun Redboard Turbo development board, and then the SparkFun Redboard Turbo development board with a micro USB to USB cable to the host computer. Run our sketch to configure the USB-C power delivery board to provide power to the NVIDIA Jetson Xavier NX. Attach the power board under the sensor board. Attach the USB-C power delivery board to the power board. Connect it with a USB-C cable to the USB-C power bank. Use a multimeter to measure 20 volts at its output. Wire up the DC barrel jack connector. Add quick disconnect terminal connectors. Connect the DC barrel jack connector to the USB-C power delivery board. Wire up the current and voltage sensor. attach it to the power board. Wire a SparkFun quick cable to the current and voltage sensor. Attach the sensor board with the power board to the top of the battery stands. Use a multimeter to measure 20 volts between the positive inside and the outside of the DC barrel jack connector. Attach the microcontroller and the sensors to the sensor board. It is easy to design a new sensor board with a different sensor suite to replace this one. Wire up the IMUs on the vision board with SparkFun quick cables. Attach the Arduino Zero development board. The temperature sensor, the IMU, the pressure sensor, and the GNSS. Here's a sensor board with a microcontroller and all the sensors. Attach the processing board to the right side of the battery stands. Attach the NVIDIA Jetson Xavier NX development board and its antennas to the processing board. It is easy to design a new processing board with a different processing platform to replace this one. Here is a processing board with the NVIDIA Jetson Xavier NX. Connect the DC barrel jack connector to the DC jack of the NVIDIA Jetson development board. Use a double-sided tape and a zip tie to hold the DC barrel jack connector in place. We attach a few more cables. Connect the USB cable from the thermal camera to the NVIDIA Jetson development board. Connect the ultrasonic rangefinder with 3 jumper wires to the UART on the Arduino Zero development board. Connect the USB cable from the RGB-Depth camera to the NVIDIA Jetson development board. Connect the Arduino Zero development board with a USB cable to the NVIDIA Jetson development board. Connect the ribbon cables from the 2 RGB cameras through the holes in the processing board to the MIPI CSI connectors on the NVIDIA Jetson development board. Now the sensors and processing board is completely assembled. Now let's work on the cover. Insert the threaded heat inserts in the front of the cover. Connect a USB cable to the touchscreen display. Attach the touchscreen display from the inside to the cover. Push the USB, HDMI and USB-C keystone jacks from the inside into the keystone inserts on the left side of the cover. Wire up the power push button. Add quick disconnect terminal connectors. Screw the power push button into the hole on the right side of the cover. Use tape to attach air filters to cover the air holes in the side walls. Now the cover is completely assembled. You may want to use the sensors and processing board without the cover to have full access to the system. Now let's put a cover on the sensors and processing board. Connect several cables to the NVIDIA Jetson development board. A micro USB to USB cable to the micro USB port. A HDMI cable to the HDMI port. A display port to HDMI cable to the display port. Connect a USB-C power cable to the USB-C power bank. Slide the cover over the sensors and processing board until you can still see the USB connectors on the NVIDIA Jetson development board. Connect the USB cable from the touchscreen display to the NVIDIA Jetson development board. Slide the cover now 2/3 over the sensors and processing board so you have still enough access to connect the remaining cables. Connect the HDMI cable from the NVIDIA Jetson development board to the HDMI port on the touchscreen display. Connect the quick disconnect terminal connectors from the DC barrel jack connector to the power push button. Now connect the USB-C, DisplayPort to HDMI and micro USB to USB cables to the keystone jacks in the cover. Slide the cover all the way over the sensors and processing board and attach the sensors and processing board with 2 screws to the cover. Voila, the sensor box. You can hook up the sensor box as a desktop computer with an external monitor, keyboard and mouse.